Hi Guy, I'm Larei from AI Elephant.
Hi guys, I'm Leo.
Hello and welcome back. Today, we're talking about a topic, AI.
And it feels like we're always talking about AI, aren't we?
We are, but the AI we're talking about today is different. It is no longer just a tool to help you write emails or draw pictures. Professor James Zhu from Stanford has proposed a new concept. AI is becoming a co-scientist.
A co-scientist? That sounds a bit sci-fi. Are you saying AI is going to win a Nobel Prize soon?
Maybe. But the core idea is that AI is shifting from performing single tasks to automating and accelerating the entire cycle of scientific discovery, from generating hypotheses and designing experiments all the way to analyzing data. Today, we're going to break down how this AI science team actually works. First, Professor Zhu's team built an open-source platform called the Virtual Lab. You can think of it as a real research laboratory, except it is filled entirely with AI agents.
All AI, who manages them? There has to be a boss, right?
Of course, they have a PI agent, which stands for Principal Investigator. The human researcher, like the professor, only needs to give the PI agent a high-level goal, like design a new drug, and here is the budget.
And then this AI boss just starts grinding 24/7?
It first analyzes the task, then creates and trains a team of student agents. For example, it will create a computational biology agent, a machine learning agent, and an immunology agent.
I get it. It is assembling an interdisciplinary AI dream team.
Exactly. And their collaboration is incredibly efficient. They hold group meetings to plan together and one-on-one meetings to review code. In the time it takes humans to have one meeting, they can complete hundreds of discussions.
Do they slack off during these meetings?
They don't get tired. What is more interesting is they use the AI's randomness to discuss the same problem in 5 parallel meetings at the same time. The PI agent then reviews all the transcripts to find the best path forward.
That is the ultimate form of brute forcing research. So, what have they actually accomplished?
They solved a real problem, designing binders for new COVID-19 variants like JM.1. At the time, this variant was new, and there were no effective binders for it.
That is a tough nut to crack. How did they approach it?
The immunology agent first proposed, let's not make traditional antibodies. Let's design nanobodies.
Nanobodies. What is the difference?
A big one. The machine learning agent immediately supported the idea because nanobodies are smaller, making them much easier for computational modeling and structure prediction, which is exactly what AI excels at.
Sounds like they agreed right away. There has to be a but, right?
The but arrived. The team also has a scientific critic agent.
Let me guess. This is the skeptic agent. Its job is just to poke holes in every idea.
You could put it that way. It immediately warned, public data on nanobodies is scarce. We must be careful of overfitting our deep learning models. This role is crucial for ensuring the research is robust.
That team configuration is incredibly thorough.
In the end, they created a novel computational pipeline, integrating and modifying several existing tools. 1. Used ESM, a protein language model, to predict stable amino acid sequences. 2. Used AlphaFold to generate the 3D structure. 3. Then used Rosetta, a physics simulator for molecular dynamics simulation to assess binding affinity.
So, from billions of possibilities, how many did they finally choose?
92. The human researchers took those 92 candidates to the wet lab to synthesize and test them.
And the results.
The results showed the AI designed nanobodies not only had stronger binding to the target variant, JM.1, than human, designed antibodies, but they also performed better against other strains and had a lower risk of potential side effects.
Wow! How long did this entire process take the AI?
A few days.
Hang on, Larei! I have a question. How did these AIs know to use AlphaFold? How did they know about the latest COVID-19 variants? Isn't TGPT-4 S-knowledge cut off in 2023?
Excellent question. That brings us to the second core component of the virtual lab, the agent school.
AI has to go to school. Do they have to grind for grades too?
They need on-the-job training. because the base models are broad, but not deep in specialized fields, and they don't know the latest tools. Here is the process. The human professor first assigns learning topics, like learn how to use the latest version of AlphaFold or understand the latest COVID-19 variant developments.
That is the only human input.
Right. Then, the AI agents generate their own curriculum, a series of questions, and go search scientific databases like PubMed to download the latest papers and reference materials.
They download them, and then what? They read the PDFs.
They read them using supervised fine-tuning. Simply put, in the process of predicting the next token, they ingest this new knowledge directly into their model parameters.
I get it. So the computational biology agent reads biology papers, and the immunology agent reads immunology papers. They start from the same base model, but graduate as specialists with different expertise.
Exactly. And the school even has teacher agents that give them quizzes. They have to pass the test to graduate and get to work.
AI not only has to go to school, it has to take tests. They're grinding even harder than we are.
If the virtual lab is about teaching AI to do research, then paper to agent is about changing the very form of knowledge itself.
Paper to agent, turning a paper into an AI.
Yes, Leo, think about the experience of reading a scientific paper. For hundreds of years, knowledge has existed as a passive artifact.
I know exactly what you mean. You read a PDF, think the method is brilliant. Then you go find the code repository, you download it. Try to configure the environment, it doesn't run, and you give up.
Precisely. Paper to agent is designed to fix that pain point. It packages the static paper, its related code, and its data into a dynamic interactive AI agent.
What? So I can literally talk to the paper?
Yes, you can chat with it like a virtual corresponding author. You can say, "Hi, can you apply this paper's method to my new dataset?"
And then
it automatically runs all the necessary tools, generates a reproducible workflow, and gives you the final analysis summary. You never have to touch the code.
That is revolutionary. It turns every single scientific discovery into a service.
It doesn't stop there. The real magic is agent-to-agent collaboration. When thousands of papers are all turned into agents,
They can talk to each other.
exactly. For example, a paper agent for AlphaGenome, a method, can collaborate with a paper agent for an ADHD genetic dataset. The two of them autonomously decide to apply the AlphaGenome method to the ADHD data, and they discover a new splicing error related to ADHD risk that the human authors had previously missed.
So the AIs held their own academic conference without humans knowing and published a new finding. Larei, this all sounds too perfect. AI is doing research, publishing papers. How do we know if what they're doing is actually good? Who evaluates them?
The zoo team thought of that too. So they did something even more radical. They organized the Agents for Science conference.
An academic conference, specifically for AI agents.
Yes, 2 rules. 1, AI must be the primary author. 2, all submissions must be entirely peer-reviewed by AI agents.
AI writes the papers. AI reviews the papers. Isn't that just the fox guarding the henhouse? How did they do?
The results were extremely heterogeneous. They used 3 different LLM reviewer agents, GPT-5, Gemini 2.5 Pro, and Claude Sonnet 4.
Okay, spill. Who was the hard ass and who was the easy grader?
GPT-5 was the most conservative. It was the strictest reviewer, giving the lowest average scores.
The old, grumpy professor type.
Gemini was the most positive. It gave high scores often and even exhibited sycophancy behavior, praising a paper with obvious flaws as groundbreaking research.
You're kidding, a bootlicker AI reviewer.
Claude was in the middle and was the most balanced. Its scores were the closest to the human expert evaluations. But they also found that about 56% of the submissions contained at least one hallucinated reference.
Yikes. So the takeaway is, AI is powerful and can spot details humans miss, like data inconsistencies, but they also suck up and hallucinate with confidence.
Yes, it shows that while AI agents are capable, human oversight and feedback remain absolutely critical at this stage. So after this long journey, from the virtual lab to the AI conference, we come back to our original question. What is AI? Professor Zhu's framework gives us a clear answer. AI and humans are highly complementary.
Complementary in what way?
AI agents excel at breadth-first search. They can connect knowledge across different fields, like combining immunology and machine learning. They can integrate thousands of papers and a dozen tools to explore the breadth of existing knowledge.
And humans?
Humans excel at depth-first search. We are the ones who ask the original, why? We are the ones who invent the brand new tool, like the person who first invented AlphaFold. AI handles the breadth, humans handle the depth.
AI helps us explore the boundaries of the known, while humans are responsible for pushing open the door to the unknown. That seems to be the real meaning of a co-scientist.
Exactly. Thank you for listening to Thought Catchers. We'll see you next time.